Hello everyone, welcome to this YouTube channel. Today I will explain on the very important topic, that is transistor. Here are some topics that I will cover on this lecture. The first one is about the inventors, then what is transistor and its applications. Then third one is types, meaning of bipolar junction transistor. Then after, physical structure of transistor, then with doping and region of operation of transistor, then symbol and why NPN transistor is used. Then after, the last and the most important topic of this lecture is working of transistor. Let's start the first sub part of this lecture, that is about the inventors. Transistor was invented in December 1947 by the team John Barden, Walter Brattain and William Shockley in the Bell Labs, USA, and later William Shockley made Johnson version of transistor in 1951. They received Nobel Prize in 1956. Now we will study what is transistor and its applications. Transistor derived from two words, that is transfer plus resistance. It means the transfer of resistance. The transistor is a semiconductor device used to amplify or switch electronic signal and electrical power. The application of transistor are used in amplification, switching, signal processing, power conversion, radio frequency applications, light emitting diode, photovoltaic cells, and etc. Now moving on the next part, that is types and the meaning of bipolar junction transistor. There are two types of transistor, that is first one is BJT and FET. BJT is a three-terminal device. The subpart of BJT is NPN and PNP transistor. It is used for amplification of weak signals. In FET, there is JFET and MOSFET. Also, JFET has N-channel JFET and P-channel JFET, and MOSFET there is also two types, that is depletion type and enhancement type. Not going in the details of this part, we will discuss the BJT. You all will be curious about that why it terms as bipolar. Because the transistor carries both electron and holes, that will be called as the bipolar. Now we will discuss the physical structure of transistor. As you can see in the image, that N side is connected to emitter, P side connected to base, and again N side connected to collector. This is transistor is NPN transistor, and in the PNP transistor, P side connected to emitter, N side connected to base, and again P side connected to collector. I will discuss the working of this transistor in further slides. In the figure, electrons are flows from N to P, and the flow of current is opposite to the direction of the flow of electrons in NPN transistor. In PNP, there is opposite work. From N to P, electrons flow. Direction of current is from emitter to base, P to N. Generally, we use NPN transistor because mobility of electron is more than the mobility of holes. With doping and region of operation in transistors, with in collector, the more in width than emitter than base. The doping level of the emitter is more than collector than base. Region of operation in transistor. There are two junctions in transistor, the J1 and J2. First junction, when the first junction is forward bias and J2 is reverse bias, this region is called the active region and also called the amplifier. Then when junction J1 is forward bias and junction J2 is again forward bias, then this region is called the saturation region. When junction J1 is reverse bias and junction J2 is also reverse bias, then this region is called the cutoff region. As you can see the symbol of NPN and PNP transistor in the shown images, the direction of flow of current is from base to emitter, and in PNP transistor the direction of flow of current is from emitter to base. Now coming on the last topic of this lecture, that is the working of transistor. Let's start. Transistor works on active mode, that is when junction J1 is forward bias and junction J2 is reverse bias. That is resistance is nearly about 0 when J1 is forward bias, and resistance at J2 is infinity when J2 is reverse bias. That is input resistance is smaller than the output resistance. So we have a weak signal at input but amplified signal at the output. So there is amplification. We transfer resistance for junction J2, that is it reverse bias. Here we can say that amplification works in the transistor. First I will discuss the NPN transistor. In NPN transistor, emitter base is forward bias and collector base is reverse bias. Electron flow from N to P and current flow from emitter to base. Battery is connected to negative side of the battery is connected to N side and positive is connected to base. When collector base is reverse bias, then it is connected to positive side of the NP transistor. When the base emitter junction is forward bias, it allows holes, that is the majority carrier in P-type material, to flow from base to the emitter. These holes combines with electron in N-type emitter, causing a large current to flow from the emitter to base. This base current controls the current flowing from the collector to the emitter. The majority carrier in the collector are holes and the flow towards the emitter under influence of the collector base voltage constituting the collector current. Similarly to the NPN transistor, a small base current control a much larger collector current. That is about the transistors. So now here we can conclude this lecture. Hope you got the right information. Please like and share this video to other students, and also don't forget to subscribe this YouTube channel. I will be again come back for another topic. Till then, goodbye. Thank you.